Welcome. This is for Cambridge A level, AS level, CIE, AS level, Probability and Statistics 1, Practice Paper 3 for the upcoming examinations. Question number 1. Each of the 180 students at a college plays exactly one of the piano, guitar, or drums. Either they play piano, guitar, or drums. The number of male and female students who play are given in the following table. A student is chosen at random. Find the probability that he plays a guitar. So, how many he plays a guitar? 44 plus 38. 44 plus 38 out of total how many people? So we need to know that it is out of 180. So when I simplify that, it becomes 41 upon 90. You can write in three significant figures 0.456. Find the probability that the student is male given that the student plays the drum. Given that. So given that student plays the drum. So after given that whatever comes that goes to the denominator. So how many students plays the drum? Check how many students plays the drum. 11 plus 20 plays the drum. So 11 upon 180 plus 20 upon 180. Now a part of it goes to the numerator. Which part? He should be a male. So probability of male intersection drum. So who are these out of this 11 and 20? Who are the students male? This 11 upon 180. 11 upon 180 goes to the numerator. So this becomes nothing but how much? The answer as 11 upon 31, which is going to be 0.355. Determine whether the events student plays the guitar and student plays the female, students is a female, is independent or not. So first of all, I'm going to find it out. Student is a female. How many females are there? We can see that add them all. 42 plus 38, which is 80, 80 plus 20, 100. So 42 plus 38 plus 820 divided by 180. So which is going to be 100 by 180, which is 5 upon 9. Then student who plays a guitar is going to be another one. Plays a guitar. So I'll take it as G. How many are playing a guitar? Just now we have done 44 plus 38. 44 plus 38 divided by 180, which is 82 by 180, which is 41 upon 90. Now what am I going to find it out? Probability of female intersection guitar. How many are people, how many females are playing guitar? 38 people are playing guitar. So 38 upon 180, which is nothing but what? 19 upon 90. So for to be what is this independent, probability of F intersection G should be equals to probability of F times probability of G. So probability of F intersection G is 19 upon 90. Then probability of F is 5 upon 9. G is 41 upon 90. Are they equal? They are not equal. Not equal. So not independent. If they are equal, independent. If they are not equal, not independent. That's going to be the answer. Now coming to question number 2. Question number 2 is a concept from what is this? Coding. This concept is from coding. So we shall start to solve it out that question. So you need to be carefully understood what is this coding question is all about. And he gave that summary of 40 values. So n equals to nothing but how much? 40. So write down first of all n equals to 40. Then the coding is x minus k. X minus k and x minus k whole square. Given that the mean of these 40 values is 34. So mean of the 40 values. So when I do the coding, x minus k upon 40, I will be getting it out. Original mean, which is that original mean minus 40 or minus k, because the coding is k minus k. So original mean minus k is going to be nothing but what? Is the value of the coded mean. Now what is he asking? Find the value of k. So now what is sigma x minus k? Sigma x minus k is going to be nothing but what? 520. 520 divided by 40 equals to 34 minus k. 520 divided by 30 is nothing but how much? 40 is 13. 13 equals to 34 minus k. So k equals to 34 minus 13, which is 21. So the coding is minus k. So therefore, this is the original mean. Original mean. And minus k is going to be the coded mean. Find the variance of these 40 values of x. So we have to find the variance of this 40 values of x. So variance equals to sigma x minus k whole square upon 40 minus sigma x minus k upon 40 whole square. So sigma x minus k is whole square is 9640 upon 40 minus 520 upon 40 whole square, which is nothing but what? 241 minus 13 square, which is nothing but how much? 72. That's question number 2. Now coming to question number 3. Question number 3 is from normal distribution. So how do I know it is from normal distribution? The keyword is going to be the normally distributed. So normal distribution question. So let's try to solve it out. PR runs a 2 kilometers running race. Now in that the mean is distributed. Mean is 10.1 and standard deviation is 1.3. Find the probability that she takes longer than greater than 11.3. So probability of x greater than 11.3. So probability of z greater than 11.3 minus 10.1 divided by 1.3. So which is probability of z greater than 0.9231, which is 1 minus probability of z less than 0.9231, which is 1 minus 0.822. So which is 0.178. On 75% of the days, PR takes longer than t minutes to run 2 kilometers. So probability of x greater than t minutes equals to 75%. 75% means 75 divided by 100. So probability of x less than t will be equals to 25 upon 100. So probability of z less than t minus 10.1 by 1.3 equals to 0.25. 0.25 is not there in the table. So whenever it is not in the table, subtract from 1. So 0.75, then swap this. So this becomes probability of z less than 10.1 minus t divided by 1.3 equals to 0.75. So 10.1 minus t by 1.3 equals to 0.674. So 10.1 minus t equals to 1.3 times 0.674. Then t equals to 10.1 minus 1.3 times 0.674. Do by calculator, you should be getting 9.22 as the answer. Now coming to question number 4. Now question number 4 is about this permutations and combinations, arranging the numbers in order. So we have to be very much careful for arranging the numbers in order. What is the word over here? The word is telescope. The word is telescope. So what is he asking? Telescope. And 9-letter words can be arranged. So how many are there? 9 factorial divided by, what is this? 9 factorial divided by 3 factorial. Why am I doing 3 factorial? Because I have 3 e's. This is for 3 e's. So answer is going to be 60,480. 60,480. In how many different ways can the 9 letters of the word telescope can be arranged so that there are exactly 2 letters between T and C? There should be exactly 2 letters between T and C. 1, 2, 3, 4, 5, 6, 7, 8, 9. So T is over here and C is over here. Exactly 2 letters should be there. So what is that? So I bring this down over here and write telescope. So T is gone, C is gone. So how much am I left over with? Nothing but what? How many alphabets I'm left over with? 1, 2, 3, 4, 5, 6, 7. These 7 can be chosen in these two places. Two have to be chosen for this one. So seven alphabets, but two places. So therefore, it is going to be nothing but what? 7C2. 7C2. So for example, any two are being done. For example, L and E are done. So next, what is that? 7, but this is choosing and arranging, right? So therefore, instead of 7C2, it's going to be 7P2. 7P2 because it is choosing and arranging. It is 7P2. Then that one, if I see 1, 2, 3, 4, 5, 6, 7, 8, 9. So that TC can come here, then TC can come here, then TC can come here, then again TC can come here, then again TC can come here, then again TC can come here. So totally how many ways you can see that? 1, 2, 3, 4, 5, 6. So that's right, times 6. 1, 2, 3, 4, 5, 6. Then again TC can also be written as this is TC, TC, or it is CT. So therefore again times 2. This is going to be the final answer. But don't forget to divide by 3 factorial. Why am I dividing by 3 factorial? Because for e's, 3 e's are there. So this is going to be the answer, which is 10,080. Now coming to question number 5. Question number 5 is from histogram. So we have to draw the histogram. In order to draw the histogram, we need to remember that we are supposed to use it out the what you call it as frequency density. We have to use frequency density to draw the histogram. So what am I going to do? I'm going to find it out the frequency density. So number of villages are given. So I will be finding frequency density. What is frequency density? Frequency divided by the class width. So 8, and before that it should be continuous. How should I make it continuous? So subtract 50 from this side and add 50. This is 850. So this becomes 850 and this becomes 1250. 1250 and 2050 and 2001, 2050 and 3150, 3250. Similarly, 3250 and 4850. So now I have to calculate the frequency density. 8 by 800, which is 0.01. This is 12 by 400, which is 0.03. 50 by 800, 0.0625. Then this is 48 by 1200, 0.04. And this is 32 by 1600, which is 0.02. So I'm going to draw the frequency density now on the y-axis, then on the x-axis is going to be the population. So let's make it out. It's going to be 50, 850, 1250, and see that how is that? Be careful over there. And maximum is nothing but what? 4,200. Maximum is 4,850, and starting from 50. So if I start from 50, and I take it as this as maximum is 4,850. Maximum is 4,850. So total is 4,800 is a gap. And how many lines are there over here? 10, 10, 10, 10, 10, 10. So how many lines are there? 6 lines are 6 tens are there. So divided by 60. So it becomes nothing but how much? 800. So each what it says, each block is going to be 800. So I'm going to write it as 800, 850, 850, 1650, 2450, 3250, 4050. So that will be the way. And over here, it's going to be 0 0.01, 0 0.02, 0 0.03, 0 0.04, 0 0.05, 0 0.06, and 0 0.07. Now, from 50 to 850 is 0 0.01. 50 to 850 will be 0 0.01. Over here, it is 0 0.01, 850. Then 850 to 1250 is 0 0.03. Where is 1250? It should be there in between 8000 and this one, exactly in the middle. It is how much? 0 0.03. It should be in the middle. Then 1250 to 2050 is 0 0.60625 till 2050. 2050. This is 2050 is again in the middle, 0 0.625. 0 0.6. Then this is 0 0.6 is over here. Then 0 0.61, 62, 625, somewhere over in the middle. Then draw that. After that, once again, till in the middle, see that we are drawing till the middle, and over here till here. So I start it out in the middle, not at the line, and once again I have to draw till here. That's better. This is 0 0.6, 0 0.61, 62, 625. So see that we draw till in the middle itself only. This should be the line. Then 0 0.04 from 2050 to 3250 till 3250 to 0 0.04. This should be easier one. So join it out. This is 0 0.04. And finally till 4080 0 0.02. And finally 0 0.02. That's going to be the answer. This is the diagram. Don't forget to write over here population and over here frequency density. Write down the class interval in which the median occurs. Median means nothing but what? The middle number. Middle number is nothing but what? 150 divided by 2. 150 divided by 2 is going to be 75. So 75th term. So write the cumulative frequencies 8, 20, 70, 118 and 150. So it comes in this period 2100 to 3200, 2100 to 3200. Find the greatest and possible values of the interquartile range for the population of 150. So first of all, Q1 is 150 divided by 4, which is nothing but what? 75, 37.5 means 38th term. 38th term. Where does the 38th term comes? It comes between 1200 to 1250 to 2050. It comes between 1250 to 2050. Now Q3 will be 3 upon 4 times 150, which is nothing but what? If I use that one, 3 times 37.5, which is going to be nothing but how much? 112.5, which is nothing but what? 113th term. 113th term, where does it comes? It comes in the 2050 to 3250. 2050 to 3250. So what's going to be the maximum one? Lower bound from here, upper bound from here. So 3250 minus 1250, which is going to be 2000, is going to be the answer. Now coming to question number 6. Question number 6 is from which concept? It is from, again, probability. So at a company call center, 90% of the callers are connected. So this is all away from the probability. So we are going to do from probability concept there. 90% of the callers are connected to a representative. So we see that 90% of the callers are being connected to a representative. So probability of success is going to be 0.9. Failure will be 0.1 out of a random sample of 12. So n equals to 12. Find the probability that fewer than 10. Fewer than 10 means 0, 1, 2, and so on till 9, which is very difficult to do that, less than 10. So what am I going to do that? I'm going to do that 1 minus probability of x equals to 10 minus probability of x equals to 11 minus probability of x equals to 12. So 1 minus 12c 10, 0.9 to the power of 10, 0.1 whole to the power of 2 minus 12c 11, 0.9 whole to the power of 11, 0.1 whole to the power of 1, 12c 12, 0.9 whole to the power of 12 and 0.1 whole to the power of 0. So which is 1 minus 0.230128 minus 0.376573, 0.282430, which is going to be 0.111. A random sample of 80 people. Now n equals to 80. And this is what approximation. So pre equals to 0.9. So mean equals to nothing but what? NP, which is 80 times 0.9, which is 72. Standard deviation equals to square root of NPQ. Square root of 80 times 0.9 times 0.1, which is square root of 7.2. Probability that more than 69. X greater than 69. It is X greater than 69. So draw the number line. 69. 69.1 is also greater than that. Then 69.2 will be rounded off to 69. 69.3 will be rounded off to 69. 69.4 will be rounded off to 69. But 69.5 will be rounded off to 66. So which is that I want require? I want to which will be rounded off to 70. I want that only. So I want that 70. It should be greater than 69. So therefore, probability of z greater than 69.5 minus 72 divided by square root of 7.2, which is probability of z greater than minus 0.9317. So greater to lesser will be 1 minus probability of z less than minus 0.9317. Now lesser negative to positive, 1 minus probability of z less than 0.9317. So 1 minus 1 plus probability of z less than 0.9317. You see from the calculator 0.824. Justify your answer. Justify the use of approximation in part B. What is the justification? NP equals to 72. NQ is also equals to 8, which is both greater than 5. If both greater than 5, approximation is valid. Approximation is valid if at all NP and NQ are greater than 5. And finally, question number 7. Question number 7 is from the tree diagram. So we need to draw the tree diagram over there. So a box A contains 6 red balls, and this one is X red balls and 4 blue balls, 4 blue balls and 9 blue balls. Box B, a ball is chosen at random from box A and placed in box B. A ball is then chosen at random. Complete the free diagram. So this is 6 by 10 and 4 by 10 is okay. Now whenever a red ball is drawn, the new composition for this one is going to be What is the new composition is going to be x plus 1 red and 9 blue. X plus 1 red and 9 blue. So what is going to be the probability for this one now? It's going to be x plus 1 by x plus 10. So let me write neatly over here so that I have to have a space. So first of all, basically ball B will be have ball A, box A will have 6 red and x red. Whereas how many blue? 4 blue and 9 blue. Now what am I doing it out? I am picking one red and one blue. So in that case, if at all it is red is being picked, now it becomes x plus 1 red and 9 blue. So what is the probability of picking up red now? What is this red over here? This will be the new composition in this case. What will be the probability in that case? It will become x plus 1 by x plus 10, and over here it will become 9 by x plus 10. Now if at all I'm placing a blue ball over here, it becomes x red and 10 blue. Then what will be the probability over here? X upon x plus 10 and 10 upon x plus 10. Show that the probability of both the balls are blue is 4 upon x plus 10. Both the balls should be blue. Both the balls should be blue means chosen are blue. So this is going to be both the balls. So it is 4 upon 10 times 10 upon x plus 10. 10 10 gets cancels, 4 upon x plus 10. Then do we have any another part? Oh, that's all. This is only very simple. One more part C should also be there. So I think so part C is missing for this question. So let me write it out the part C for that, because part C was missing. Let me pick it out the part C question for this one, because it did not come over here. So let me write that part C. It is given that probability that both balls chosen is are blue. Blue is 1 upon 6. Then both balls chosen is probability are blue is 6. Find the probability that ball chosen from A is red, given that ball chosen from B is red. What is the meaning of this question? Let's try to understand the meaning of the question. So what is he saying? That it is given that both the balls chosen are blue is 1 upon 6. Both the balls chosen are blue is nothing but what this one. So 4 upon x plus 10. So 4 upon x plus 10 equals to 1 upon 6. So x plus 10 equals to 24. So x equals to nothing but what? 14. So we got the value of x is 14. Now, what is he asking? Find the probability that the ball chosen from A is red, given that the ball chosen from B is red. So probability of A red, given that it is B red. So how am I going to write it out? The denominator is going to be probability of B red, and numerator is going to be A red intersection B red. So probability of ball B to be red. Ball B to be red. Ball B to be red is nothing but what? Either this one or this one, which is 6 upon 10 times x plus 1 by x plus 10, 4 upon 10 times x upon x plus 10. So which is going to be 6 upon 10 times x plus 1 by x plus 10, or 4 upon 10 times x upon x plus 10. This is ball B is going to be red. Now in this one, what is it? Ball A also has to be red. So A red and B blue. What is this? A red and B blue. So this is from A red and B blue. So which is A red? So this one goes to the numerator. So 6 upon 10 times x plus 1 by x plus 10. Now what is x value just now? We got it out 14, right? So 6 upon 10 times 15 upon 24 divided by 6 upon 10 times 15 upon 24 plus 4 upon 10 times 14 upon 24. Simplify that. 3 upon 8 upon 73 upon 120, which is going to be nothing but how much? 45 upon 73. That's going to be the answer. Write in three significant figures, 0.616. This is going to be the answer for that question. So that completes that paper. See you in the next paper. Bye.